All right, so continuing along in chapter 12, section 4 is on quadratic functions, okay? Now yesterday we remembered about linear functions, okay, that they were first degree, okay? Y equals mx plus b, or if we're using functional notation, we'd call it f of x equals mx plus b. All right, these were first degree. The highest degree you saw was a 1, an implied 1 exponent, okay? Quadratic functions are second degree. The highest degree you'll see is a 2, okay, an exponent of 2. So y equals x squared, or f of x equals x squared. This is going to be a quadratic function. It's not going to be linear. Its graph is going to be what we call a parabola, okay? And theoretically, remember, as it goes outward, it's going up, all right? So it will pass the vertical line test, okay? So there is a lot in this chapter. I'm going to just expect the bare minimum, okay? What I want you to be able to do is recognize and plot the parent graph, the basic quadratic function. So if you have y equals x squared, or f of x equals x squared using functional notation, you would make a table. Because it's not linear, you have to do more than 2 points. So let's do 0, 1, negative 1, 2, and negative 2. So we're plugging in for x all of these different values to see what we get, and then we'll plot it. So if we plugged in 0, 0 getting squared is 0. If we plug in 1 for x, 1 getting squared is 1. If we plug in negative 1, now think about what we have here. We have negative 1 getting plugged in and squaring it, so that would be positive 1. If I plugged in 2, 2 squared is 4. If I plug in negative 2 and square, a negative times a negative is a positive. So if I plot this, I'm going to be at 0, 0, and it'd be at 1, 1, and negative 1, 1. And then it'd be at 2, 4, and negative 2, 4. And so this is not going to be a line, but it's going to be a parabola. Okay? So that is the basic graph of f of x equals x squared, a quadratic function. Okay? Now, like I said, this could be x squared plus x minus 3. You're going to see the book has a lot more to it. Again, I'm making life as uncomplicated as possible. But let's manipulate this graph just a little bit. Let's say that we want to alter this, and let's make this 3x squared. Okay? So the parent graph looked like this, the basic one, the f of x equals x squared. So we call this the parent graph. So you could kind of have that there and just have it dotted so you kind of remember what the basic one looked like. But if we multiply this by 3, let's see what happens. If I plug in 0, 0 times 3 is still 0. If I plug in 1, 1 getting squared is 1 times 3 would be 3. If I plug in negative 1, that means I'm saying negative 1 getting squared. I do my exponents first. That's 1 times 3, still 3. If I plug in 2, 2 getting squared is 4. 4 times 3 is 12. Negative 2 getting squared is 4 times 3 is also 12. So let's see what happens in this graph, okay? I'm going to change the color. I hope you guys can see a different color. So it's still at 0, 0. It's at 1, 3. So let's see, that was 1, 2, 3. Negative 1, 3. Then 2, way up here at 12. All right, so this is going to be like way up here. Okay? So this is going to be really, really, really skinny and tall, isn't it? So while the parent graph, the basic x squared went like this, 3 multiplied by it made it like skinnier and stretched it, right? Okay, and the higher this number is, the more skinny and tall it will be. Now likewise, if I said y equals negative x squared, then everything's going to go this way, right? Instead of going 1, 1, it'll go 1, negative 1, negative 1, negative 1, and so forth. So negative in front means it's going to revert or be a reflection. It'll go downward. And if I change this and did y equals maybe 1/4 x squared, let's see what that's going to look like. Let's erase this and let's plug in. I'm going to have to change colors again. Boy, I sure hope you guys can see these colors. So let's plug in to this y equals 1/4 x squared. Let's plug in 0. Well, 0 times 0 is 0, right? Okay. If I plug in 1, 1 getting squared is 1 times 1/4. It's going to be 1/4, isn't it? If I plug in negative 1, negative 1 getting squared is still 1 times 1/4 would also be 1/4. Okay. If I plug in 2, 2 squared is 4 times 1/4 is 1. If I plug in negative 2, negative 2 getting squared is 4 times 1/4, so it would be a positive 1 as well. So what will this red graph look like? Okay, 0, 0, 1, 1/4, negative 1, 1/4, 2, 1, oh my goodness, negative 2, 1. So look what happens here. Oh my goodness, this is fat and flat, isn't it? So that parabola kind of flattens out. So when a fraction is in front, it's going to flatten, right, and get kind of fat and flat. But if it's an integer, it's going to be taller and thinner. Okay? So that's the basic things that I want you to know about quadratic functions. There's a lot more, but that's all for right now. So instead of a try this, let's see, I want you to do, let's just do one right now. Let's do f of x equals 2x squared. And then let's do g of x is 1/8 x squared. Okay? So do those two for me. Stop the tape. Make sure you know how to do them. right, so hopefully you did a table and plugged in my values. Made a nice, tall, skinny graph there. And this one, man, oh man, let's see, 0, 0, 1/8. And this goes up a little bit. So this thing is going to look like that. Okay? All right, so refer to RenWeb. Best wishes. Call me if you need me.